Dr. Shamsuyeva has received her doctor's degree in chemistry at the University of Braunschweig, and she is currently head of department Plastics Technology, Recycling and Plastics Analytics at the Institute of Plastics and Circular Economy at the Leibniz University of Hanover. Her research focus right now is with polymer analytics as well as recycling of thermoplastics and textile. I'm looking forward to an interesting presentation and hand over now to Dr. Shamsuyeva.
Thank you very much for the invitation and for the very nice introduction. Today, I would like to give you a short overview about the plastic recycling in the circular economy from the perspective of the scientific institution, and I will talk about definitions, characterizations, and standardization of plastic recyclates. First of all, I would like to shortly introduce my institution and the University of Hanover University. So basically, it is one of the oldest 9 universities in Germany. It offers around 84 degree programs and includes 9 faculties. The Institute of Plastics and Circular Economy belongs to the Faculty of Mechanical Engineering and is located in Research Campus Garbsen, where you find 20 institutes of the mechanical engineering faculty. And all of the institutes specialize in different fields and work close together with academia and industry. So basically, the history of the institute starts in 1999, where Professor Enders received his first professor position at the Hanover University of Applied Science and Arts and set up Institute for Plastics, for Bioplastics and Biocomposites. And later on, 2013, his research group was extended to Application Center of Wood Fiber Research. So basically, the research focus was extended from bioplastics and biocomposites to textile composites and hybrid composites, and as well as recycling. And since 2019, the nearly half of the research group, together with Professor Enders, came to the Leibniz University and set up a new institute which has a research focus on plastics technology and recycling. Besides other research focus, we work a lot with standardization and different plastic analytics. In the next slides, I would like to provide more information about these research topics. So basically, the plastics is, on the one side, it is amazing, innovative, and unique material. On the other side, it is still, it is always criticized about its bad environmental effects and challenges with the recycling. But it's important to keep in mind that plastics enabled a lot of things in our world: medicine, electromobility, transport. All of these trends would not be possible without plastics. So I think we need to be thankful for to the plastics that we have these possibilities. But at the same time, these materials with their very good performance, mechanical, thermal, first of all, the properties itself, at the same time, the durability of these properties. But still, due to different reasons, the society uses these materials for products with very short lifetime. Basically, a lot of single-use products are made of plastics. At the same time, especially in the last year, during the last year, we saw that the plastic material offers very important products, and we don't have any alternative for this material. So the only way to make this material more useful for the for our daily life is to find solutions to integrate it into circular economy. If we have a look to the plastic material flow nowadays in the field of plastics, this is the numbers, the statistics was refers to the Conversia market study, and you can see how complex it is. So we have some feedstock, renewable and fossil, which then goes to the converting and consumption, and after consumption, as it passes to the use phase in different fields, nearly 75 million tons is just unknown plastic waste, which is somewhere in our environment. At the same time, nearly 75 million tons is landfilled, which is also not the best solution. So basically on this slide, you can see that there is a lot of, there is a high demand on a solution, and we don't have so much time to for the discussion of how to perform this solution. But still, the main point is that we need a high quality plastic recyclates and processes which enable this quality. So what is the challenges of the recycling economy? Why do we cannot have it today? So basically, the main difficulty is that the quality of the recyclate, it's not only the quality of a certain recyclate, but it should be performed over a certain time. So if there is a company which wants to use plastic recyclates as a feedstock material, so they need the same quality of recyclate over years in the same amount, so it should be also sufficient amount with a certain quality. In order to receive or to realize this demand, it is important to have a clear standardization standards in this field, and also this part is still in the development phase. The next point is the technical data sheet. So if a certain company or producer, plastic product producer, wants to use the materials, the recyclates, they need to have a technical data sheet. What is the material properties of the recyclate? Mechanical, thermal, processing properties, and who's responsible for the developing of these technical data sheets? Who is responsible for the numbers which are stated in these technical data sheets? Even more complex is the topic regarding safety data sheets. So the value-added chain of these plastic recyclates is very long. And which of these stations is responsible for the security data sheet? Further difficulty is the monitoring and documentation of the input stream. So input stream is the material which enters the recycling process. Is it the recycler or the some sorting factory? So there are a lot of questions, but this field is in the development phase, so it is important that all of these points are considered together. This was the main motivation for the IKK to be involved in the standardization point, in the standardization activities, because as a research institute, we receive a lot of inquiries where companies, where industry wants to develop a new product or process for the use of plastic recyclates, but still they don't get the material, or they have some product problems. And but we noticed very early that the problem is not only technical, but also there is no universal definitions. So wording is a problem. The characterization of plastic recyclates, what I just mentioned as a technical and safety data sheets. The recycling processes are very different, and the product also. So we need to have a little bit more structure in this structure and clarity in this field. Now, IKK is a member in 3 different DIN committees. DIN is the German Institute of Standardization, and the DIN spec, this is a specification, so it is like draft of a standard. It was initiated by Surplus, and the consortium leader is IKK. So in this case, we have 1 year to develop a DIN spec, which is would be used for the standards for trading and processing of plastic waste, feedstock, and recyclates. So the focus of the DIN spec is to work with to define definitions, to make clear definitions and sum up existing standards and define the used wording in the plastic recycling. We define the quality grades, so there are 4 quality grades which are defined according to the data information available on the materials. Transparent and clear labels regarding the type of recycling and recycling content, processing of handling and of the plastic waste, entering then the recycling process. And this DIN spec is the first project in this case, which in this field, which is so large and so extensive, so that we can use this as a starting point for the next standards in this field. But now I would like to talk a little bit about the these 3 stages, which are which are associated with the challenges regarding definitions and products. These are waste material, recycling process, and final product. Basically, the waste, which this journey from waste to final product is very long, and I tried to just a second. So to have my laser point. So this journey is very long, and at each of these stages we have some co-products. So these are products which can be used for other applications or sold. At the same time, each of these stages has some waste which cannot be recycled and has to be disposed. And if we talk about waste, according to the existing international standards, there are 2 definitions about which can be defined into post-consumer. So the material which is generated by the end users of products, which has fulfilled its intended use and purpose and can no longer be used. The pre-consumer, or sometimes also called as post-industrial material, is the material diverted during a manufacturing process. But still, there are a lot of, it seems the first sign that it's all defined and it's all good, but still there are a lot of points which are not clearly defined because they are between them. For example, if we think about a company which produces packaging films, and these packaging materials, some of them are used for the production and some of them are used for the transport. So the purpose of some of these materials is end purpose, to be used as a transport material. And for other ones, it is the post-consumer, because they are, pre-consumer, because they are used just as a part of the production process. So, and this is just the simplest example, and there are a lot of further examples about, if we're talking about the products resulting from defect during production, or if the facilities are program to another mode. There are always certain material which is produced as a waste. And currently, it's not possible to define any clearly define this material as post-consumer or pre-consumer. If we are talking about recycling process, we have certain material which enters the recycling process. But at this point, there are very different recycling processes which are available nowadays. These are, most of them, everything except solvent-based recycling are defined in international standards. But still, for example, enzymatic or biological, also sometimes called as organic recycling, in this case, we don't get a material at the end. So these products, this waste is not landfilled or lost in the nature, in our environment, but still, this is not a material which can be reused for technical application. So maybe it's not so good to handle all of these processes as equal. But still, there are further processes like solvent-based recycling or mechanical recycling and chemical. The mechanical recycling is currently one of the mostly used. So basically, in this case, there is no depolymerization, so the material is still in its form as a material, but there are certain pre-treatment stages, like for example washing, grinding, and then extrusion, filter-based extrusion, and final injection molding, and the material is used in a for the next application. So this is very, very simplified procedure. It can be much more complicated depending on the certain product applications. In the case of chemical recycling, the polymer is broken down to monomers and used for the generation of a new feedstock materials. Basically, the mechanical and chemical recycling processes are mostly used nowadays. But still, if we talk about definition of recyclate, the material which comes out of this recycling process. So we already discussed input material, and this is output material. The current definition of an international standard says that the recyclate is a plastic material resulting from the recycling of plastic waste. But in the case of chemical recycling, we don't have plastic material resulting from the recycling. So we have some feedstock which can be used for the production of new materials for plastic industry. So this definition is mainly focused on the mechanical recycling. Secondly, there is no regulation regarding used recycling processes. Secondly, the definition of the recyclate the documentation and monitoring of the recycled content is not so clear that it can be used for different recycling processes. For example, in the case of chemical recycling, usually it is the mass balance approach which is used. So it is documented how much waste enters the facility, and during this manufacturing process, it is mixed with the virgin material, and finally, as output stream, it is monitored how much recycled content is in this material. But still, physically, it's not possible to define and distinguish the virgin material from recycled material. And secondly, if we buy a plastic product with a label specifying that certain % is recycled, it is not possible to analyze whether exactly these individual products really contains this amount of recycled material. But due to the existing standard, it's not possible to define this. Consequently, there is a need for update of these definitions. And finally, if we talk about definitions in the final product, which is mainly a part, generally it is part recycled and partially recycled and partially virgin material. Then we need to look to the standards for certain plastic materials. For example, this is European standard for polypropylene, which you can see on the slide. And basically all of the plastic specific standards are built up in the same way. So we have some required data and there are some optional data. And the recycled content is one of the optional data. Optional means the company which uses this standard for characterization of its polypropylene recyclate is not it is not mandatory to give this data. It is optional data, and if it offers some advantage for the product, the company can provide these numbers, but it is not obligatory. Same thing is valid for all other properties which are defined on the under optional data, so ash content, bulk density, and so on. But for the company which processes this material, these data are very important. Or also for the one who uses these materials as for the final product. If we look at the further standards, for example, polystyrene, polyethylene, and so on, so you can see that in all of these other cases, the recycled content is not even defined even as optional data. So this is a table from one of the prior publications. The table is very long, but basically what we have done here is we summarized this table for all of these different plastic materials to provide an overview which technical data are mandatory and which technical data are optional for the characterization of different plastic recyclates. So you can see the recycled content is one of the data which is basically not even defined in in most of the plastic specific standards, although this is very important data. Another different point is the quality of the required data. For example, color. It is mandatory in all of the plastic recyclate standards, but still, how should it be defined? And in this case, you can see that it is visual examination. So basically, there is a person who says, this is black, this is white, and so on. And of course, this is not the best way to characterize a material which has to be used as for the production of new materials, because we want to have the same color for all plastic materials during their use phase. Secondly, it is also associated with some effort during the optimization of the color. It is, if you have a bright color, it is easier to make it darker, but vice versa, it's much more difficult and it's also much more expensive. So we need to define the quality of this data, how this data should be defined for certain materials. And these are only two examples, so this table is very long. So basically, the definition of the term has to be updated with regard to waste type, recycling process, and recycling content. Secondly, there are some existing standards on the characterization of polymer recyclates, on wording, but still they have to be updated because these were very first steps of the plastics industry towards circular economy, and it's very nice that these steps have been done. But still, now we observe very dynamic growth of the field, and it is important to make more clear to improve the traceability and understanding of these definitions, and it also should be universal. A lot of discussions are performed about the mechanical versus chemical recycling, because these two recycling processes are used the most, and both of them have their advantages and disadvantages. For example, if let's talk about quality of the output material. In the case of mechanical recycling, it is proportional to the quality of the input material. So if we have a very pure, stable input material, so the quality of the output material is going to be of the same quality. On the other hand, it is quite difficult to make. Difficult means expensive. Sometimes also technically not possible to make a high quality product from a very low quality input material. Because there are always further additional steps required, and materials like additives and so on have to be added in order to improve the quality. On the other side, in chemical recycling is capable of manufacturing of very high quality materials, recycled materials, which are suitable for applications in very sophisticated fields, like, for example, medicine or some scientific applications. But still, for example, the possibility of decentralized processing. In case of mechanical recycling, it is possible. So small SMEs can have the possibility to provide receive this procurement for the procurement of the facilities, and are able to perform mechanical recycling. On the other side, the chemical recycling needs really technically challenging facilities, and currently it can be done, can be performed only by large industry companies. So it is more central processing. So basically, both of these recycling processes are very valuable, and it is important to see for which application, for which product, and in which case they offer, they are suitable. Another important point is that the monitoring of additives, which is challenging for both of these recycling processes. But in any case, during the use phase of the product materials, we need to have additives in order to get a good quality mechanical, thermal, coloring, and various materials are used for this aim, like fillers or different reinforcing components and so on. But still, we have a lot of questions about how do these additives act during recycling, and what kind of effect do they possess on the quality and on the properties of the plastic recyclate. Even though there are a lot of REACH conformity declarations, but still, from the technical point of view, there are a lot of questions. As I already mentioned, there are still a lot of questions in the field of plastics recycling, definitions, characterization, standards, but still the plastic recyclates are already available commercially. So this is a very exciting and dynamically growing field. But still, we need to make further steps so that it works better. And it's very important that the first steps were already done, so we have a basis, and it works very well. So I'm really very optimistic about the future of the plastic recycling. Of course, plastic recyclates always compete with the virgin materials. And in this figure, you see a simplified figure representing these advantages and disadvantages regarding cost and quality as well as performance, because at the end we are talking about circular economy, so the price is important. There are certain recyclates which do not cost anything because companies want to get rid of them, and they pay for the disposal. At the same time, these materials in general don't have high performance and quality. There is a second group of plastic materials which have to be which you have to buy, but still the quality difference between the plastic and virgin materials is high. So the virgin materials have significantly better quality. And finally, there are also some plastic recyclates, very small amount, but which are very high quality and performance, but still they are much more expensive than the virgin plastics. And in order to change the situation and make the plastic recyclates competitive, it is important to make these clarifications, definitions, wording, characterization and standards, because it's important that the materials recyclates are available in a reproducible quality in sufficient amounts. And our first project, together with a surplus, is the DIN spec specification, which will be available for the comments of also from external partners in October 2021. Now we are working on this project, and in October it will be available in internet on the DIN homepage, so that you can also comment from your side, and afterwards these comments will be also used during this finalization of the document. Exactly. Sorry, in October it will be finally published for the use, and in May 2021, so in 2 months, it will be available for comments. At this point, I come to the end of my presentation. Here we can see some more works or some interviews from the IKK regarding recycling, circular economy, and plastics recycling. So if you have interest, and you can look at this, have a look at these documents, or you can also contact me. You can see my email on the slide. Thank you once more for the invitation and for this very nice event. Thank you very much.